Okay, we are good to go. Perfect, thank you. Then again, welcome everyone. And let me start by introducing Tyler Rayner, who is today with us, who will be leading this lecture. He's a software developer and an entrepreneur with expertise in the field of satellite data and Earth observation. He worked in a broad set of software areas, from applications to system frameworks to network security. And he's responsible for developing the Orbiter for iPhone and iPad, which was the app that was the winner of 2021 Copernicus Masters Challenge, and as a Digital Twin Earth Challenge as well. From what I gathered, Tyler is very motivated by the projects that have the potential to create positive change, especially within climate emergency. And today he will be talking to us about humanizing scientific data. So again, welcome, and the floor is yours.
Thank you. Thank you for the intro. It's a pleasure to be here with you all today, joining you from California here. And it's nice to see everybody here on the call. A little bit of background about me. I grew up around technology since I was a little kid, always into computers and programming. Started back in the 80s, originally on an Atari, and then moved to a Mac in 1984, and then briefly to a Next, and then back to Mac. But I've seen all the changes that happened in the field in that time. And so I've kind of, as an observer, I've seen the things that worked and the things that impacted people and the things that didn't work. And I've always been struck by the importance of design and visual design, user experience design, in terms of really making a product successful and making it connect with people. Now, as you heard, I'm here because I worked on an app called Orbiter. That was a new direction for me back in 2020. I was bored with the field of software I'd been working on, the network security stuff, and I'd been doing it for so long and nothing new was happening. And I discovered this vast amount of scientific data that's collected by these satellites, Copernicus and NASA's satellites, and all this incredible data that's out there in the public domain, but difficult to use, difficult to sort of get yourself wrapped around and absorb that data. So Orbiter really was a project to try to make that data more accessible and to try to use it in new ways that might connect with people. And there have been, I think, throughout history, some really interesting examples of times when a paradigm shift happened in a technology, not necessarily because technology advanced, but because people just started approaching it in a new way. And one example that I always think of is going back to 1984 when the first Mac computer came out. And computers before that had been very techie things. There were, IBM PCs and Apple IIs, and they were all text-based, and you sort of had to be a computer person to get into them. And the Mac threw all that out, just totally started with a fresh slate and introduced these concepts like metaphors. The computer was like a desktop and you had files and folders on it. We take all that for granted now, but it was brand new back in 1984. And it totally changed people's relationship with the computer. People started giving their computers names. They became friends with their computer almost, in a way. And it was, I think, in a lot of ways, the most clear example I can think of a technology that had been cold and lifeless and got made human and got made accessible and warm and welcoming, mostly through design. Another example, 2006, Nintendo came out with the Wii. I'm sure a lot of you remember the Nintendo Wii. And this was during a time when the other console makers, Sony and Microsoft, they were very much wrapped up in a performance war. They were trying to outdo each other on performance specifications, come out with, the system that could render the most triangles per second, et cetera. And Nintendo, instead of trying to compete with that, they said, no, we're going to do something different. And so they innovated by making these controllers that were totally new and novel, where, you know, instead of playing games the way you used to, you'd play tennis and golf games with the controllers and stuff. And performance wise, the Wii was a really weak system compared to an Xbox or a PlayStation of that era, but it didn't matter because people wanted to use it and it was fun and they liked it. And it outsold both of those consoles in that generation by a huge margin. And that's sort of an example of design coming in to save the day and sort of to trump technology in a lot of ways. Now, the thing about those examples, both with the Mac and the Nintendo Wii, is that the technology wasn't really groundbreaking. It was, you know, using the same chips that were readily available. It was just doing it in a new way that had a different motivation. It was all about the experience. They all capitalized on something. They saw that there was a hole, something that wasn't being done right. And I think in some ways there are opportunities like that right now with space data, because when you think about space data and satellite data, in a lot of ways, that's the very pinnacle of techie. I mean, that's technology in its most advanced form in a lot of ways, but also it has the potential to connect with people, I think, on a very emotional and visceral level, because when you think about a satellite orbiting the Earth and gathering data and collecting images and collecting readings, the Earth is something we all have in common. And there are a few things that we're all, as humans, so connected to as the planet. So even though it is a very technical sort of field, it also has the potential to communicate with people and connect to people. And I think it's so important that we find ways of doing that now with the crises that our planet faces right now. It's a long road, though, to take that data that's coming from sensor readings on the satellite and make it into something that people are going to want to engage with. So, so what are some thoughts on how one could go about doing that? Well, what is a technology product? What is an app or a website or anything? One way of thinking about it is like a series of connections. I often think about them that way because you can break down most tech projects into thinking about the connections between their various elements. So let's look, for example, at we'll take space data. We'll take satellite images coming from, let's say, a Sentinel-2 satellite of the planet Earth. So what's the pathway that data takes? Well, first of all, it's collected by the sensors on the satellite. It goes into the computers on board the satellite, gets encoded into binary, and sent through the antenna down to Earth, where it's collected by base stations and processed, ends up going on ESA's servers and forms where it's available to download. And so that whole part of the chain there, that's just ESA's part of it. That part is already done. But then to make it something useful, you have to further make more connections. And so you have to have your own server that's processing the data. That data has to be presented to the user through a web client or an app. And within there, you've got code that's taking the data and rendering it and drawing it out into tables and text, et cetera. And so it's this sequence of connections that happen. You can trace it all the way back to those satellites if you think about all the connections. But in that chain of developing a software product, there's the element of design comes in only right at the end there, sort of right in that last connection as you're taking things and presenting them to the user. That's the step where design comes in. And it so often gets neglected. When it gets neglected, the project almost always suffers because it has to be a focal point in the design process. Design, in a lot of ways, in a tech project like that, it's the most different step in a lot of ways, because it's not coding and it's not databases and connections and that. It's more of connecting with the human, the user of the project. And so it's the only real direct piece of connection between the technology to the user is the visual and user experience designs. So I've worked on a number of projects with designers over the years in various contexts. And I've seen at times this sort of conflict tends to crop up between the science and engineering side and the designers. And there are, designers tend to have ideas about engineers, engineers have ideas about designers, and sometimes they butt heads with each other. I'll give you an example. I was working on a project. This was when I worked at Apple, and we were doing a new version of QuickTime Player, which is the video player in the app. And some very close coworkers to me were working on this project. The designers had come up with a requirement where the video window, the window that you're watching the movie in, needed to have rounded corners, just like a little 10 pixel corner radius around the window. It was very important to them, but the engineers pushed back on it and they said, no, we really can't do that because it's going to use about twice as much CPU power just to round off those corners. This was back this is 2007, maybe. Technology was less sophisticated on the hardware side. So to do something like that, you would have to put it through an additional rendering pass to round off the corners. And it would have lowered battery life, used too much energy, lowered frame rates, etc. And so the engineers pushed back, but the designers would not relent on that. And so it created this point of conflict where the engineers could not see what was so important about these rounded corners on the window. What's so important that you're going to sacrifice the performance of the project, but they would not let it go. And correctly, the way the outcome to that transpired was the engineers figured out a way. Yes, doing it the way they initially thought of would have used too much CPU, but because they couldn't just say, no, we're not doing that, they sort of had to figure out a way. And they did figure out a technique for giving those rounded corners without sacrificing performance too much. So that one worked out, but that's the sort of compromise and working together that I think is so important. Because I've heard so many times when engineers will say, well, the designers are just being picky and they're nitpicking over little things. And then the designers will say the engineers are being stubborn, they won't listen to us. They won't do what needs to be done. But both of them, they both have their reasons. And so I think it's so important to work together and listen, not just in this field, but of course in so many areas of life. But as long as everybody is on the same page in terms of trying to build a really good product, then these different perspectives and these different sources of input coming from the tech side and the design side, they're all valuable. And on most projects, you have to remember that the end result, it's not necessarily as you see it in your head as you're developing the project. It's sort of a combined picture that's being put together by all the different stakeholders. And so the designers may have a vision that they want to see that the engineers don't understand just yet. And it may at the time create extra work. It may seem too difficult for what it is. But often in the end, when you see the result, you realize, yeah, it did make sense to put in all that extra work. So it's important to not overlook design. It has to be a part of the process. It lowers the barrier to entry. If you've got good design, if you've got a really welcoming, simple interface, it will appeal to more people than if you have something that's just kind of built for your own technical colleagues. And even for internal projects or non-commercial things or little side projects, I think it's so important for design to always come in and play a role, to really focus on the user experience. So I think there's so much opportunity now with space data, kind of because of what I said before, where you've got an unbelievable amount of data out there in the public domain. And I know some of you have probably have looked through the offerings in terms of satellite data, but just to cover sort of a quick overview of what's available to maybe give you some ideas. You've got access to Earth imagery, heat maps for land and sea, snow cover, ice cover, air pollution, fires, water topography, algae, vegetation. And this is data that's all available. All the things I mentioned are pretty well defined now. There's some other kind of more experimental data inferences that are being worked on, but you can get at all that data that I mentioned, and you can use it however you want because it's public data. So I've been thinking about, ways of using it, and I'm thinking maybe you could have something like a micro app, just a little app that does one thing, maybe like a sea ice cover app where you just open this app or whatever, and it'll show you, what if you opened your phone and it has like a nice line art drawing of the poles, the North and South Pole with the current outline of the sea ice. Maybe it tells you what the percentage of sea ice is. Something like that would be, that's not hard to use. It's just something you open and you can very visually see what's going on. And there's something so cool, I think, about having data that's not prepared for you. Somebody didn't make that drawing based on satellite data. It's actually coming directly from the server to you. And, you see those ice caps, and that that's real data as observed by the satellites. So that's one idea. Another, what about something like a space selfies app, selfies from space, where every time one of these Sentinel satellites overflies you, you might get some little notification or something and see the latest satellite image that was taken of your location. Or what about looking at fire, which obviously that's becoming a bigger deal every year. The wildfires are awful this year. And what about just having something that shows you how much of the world is on fire at any given time? I used to work in New York City, and there's this thing there called the National Debt Clock. It's basically just a sign on a building that has lighted numbers on it, and it goes up. It's continually going up, showing you the current sovereign debt of the United States. And it's been up there for decades. It's as long as I can remember. But it's so simple and so powerful because it's just there. It's just one number, and it's just kind of in your face, and you see it all the time. And so I think that sign, even though visually it's really quite ugly, just in terms of the impact it makes, I think it's a really good example of good design because of how simple it is and how clear it is. So I think there's a lot of potential to be had if you think about using satellite data in those kind of ways, in ways that are really simple, but using real data. One beauty about using data directly from the satellites is it's so impartial. People haven't modified it. People haven't injected their own analysis into it. It is what it is. The data is clear and it's accurate. So when you look at data of the amount of fires that are happening currently in the rainforest, then you know that deforestation is a real problem. And it's more powerful to see it that way than to have somebody tell you. There are still, a lot of people who don't believe that climate change is real or that the polar ice caps are shrinking. And it's so easy to show it if you just look at the data. It's so clear and it's so irrefutable. So I think not a lot of people have access to that data in its raw form. The power of that data to communicate is still largely untapped. And I really hope that we'll start working on it and making some headway in that area. Another little app that I made recently is something called Fires from Space. And that's on the web. You can go there. Actually, firesfrom.space is the URL. And what that's doing is taking wildfire data from the US and Canada. When new wildfires come up, it then looks for Sentinel-2 satellite photos of those fires and puts them on a website. So it's totally automated. And it's another example of making something visual. You can hear people talk about how big these fires are, but when you actually see a photo of it from space and you see this massive burning front of it and the smoke plume coming out, then you realize, wow, there really is a huge chunk of the earth that's on fire right now. So there's no more powerful communicator than that direct kind of visual approach. It works so much better than words because people are mistrustful of words. If you talk about something, people might think you have an agenda. But that's the beauty of these satellites, is that they're just pure sensors. They have no agenda of their own. We also now, as far as new technologies and buzzword type stuff, We have AR to think about, augmented reality, and there are some encouraging hardware developments happening now with AR, with more advanced headsets. So we might start thinking about using AR to communicate some of this stuff. I think it's still very much in its novelty type phase, but you could imagine putting on a headset and having sort of a twin of the earth, a digital twin of the earth that you could interact with, and you could change overlays and things like that. So that's a slightly bigger project, but something to think about. So ideas like that they don't come automatically. They're not necessarily easy to get, but when you get a good idea and you really feel that it's got potential, don't talk yourself out of it, would be my advice. There are ways of making it happen, and dream it up in your head and get a picture of how you want it to look and really solidify it and keep thinking about it and write it down and get it on paper, and kind of every day just keep it in your head and keep building it in your head and visualizing it. Visualize how you want this thing to look, what you want to create, and then you can find the right people to work with. If it's a good idea, people will get fired up about it, and you can work with them across disciplines, work with designers and engineers together. And collaboration like that can be such a beautiful thing, and it's so satisfying to have different people, bringing different things to the table and bringing things to life. There's, always be wary of that response. If you have an idea, always be wary of that response where people say, "Oh, it can't be done," or "It's too hard, it's not realistic," because there are almost always ways of getting things done, within reason. There are always little tricks or little techniques you can use to make things happen. So the idea, that video player app I told you about, that's an example of it, where initially the response was, well, the rounded corners can't be done. It just can't. It's going to use too much CPU. But if you really are committed to making it happen, you can find ways of doing these things. And so there is right now with space data, in a lot of ways, space data has been around for a while, but still it feels very much to me like a new frontier in terms of possibilities and tools and things that can be built with this data, because the difference in terms of the volume of data that's out there and the volume that's really being used for end user focused materials is huge. There's this wealth, like a gold mine of satellite data that could be applied to communicating and solving problems. And it's just a matter of figuring out how to use it, figuring out the right ways to get it into people's hands. So I think really what I want to convey is just, if you have an idea, talk about it, talk to people about it. Don't talk yourself out of it. Don't think, oh, it's going to be too much work, because when you get collaborations going with good people who are on the same page and people who are motivated and want to bring these projects to reality, it can really happen. And the results can be so encouraging. And there's nothing more satisfying than having had an idea in your head, working really hard to bring it to light, and then seeing the end result and having people delighted to use it. It's a great feeling. So I hope that this week you've been exposed to some interesting subject matter in this field, because it really is a great field to be working in. And I'm excited to hear ideas that come out of this. And I hope that this is the start of sort of a new momentum in terms of thinking about space data beyond just the technical, beyond staying within that realm of bits and bytes and programming, thinking about it more broadly in terms of bringing it to the people, because that's really ultimately, I think, the goal of these missions, of these Earth observation missions, is communication and broadly disseminating this data and the message that's contained within this data. So I think that concludes what I had planned to talk about. And I think, are we going to do a little open session here, a question and answer or something?
Yeah, definitely. So if anyone from the participants or people who are watching us on YouTube have any questions, people on the Zoom, please just raise your hand, or if you are on YouTube, just drop a comment. Don't be shy.
I have a question regarding your app. Can you tell me what inspired you to create this?
Sure.
Yeah.
It was back, I started working on it in 2020, right around the pandemic when the lockdowns started. And it was actually the seed of the idea came from wanting to go on a camping trip with my family. And this was around April, and we were going to go camping in the mountains. And around that time of year around here, there's still often snow up in the high mountains. And because of COVID, all the ranger stations and things were shut down. So I couldn't get information on the condition of the mountains up there and whether or not they were full of snow. I had no way of knowing. And so I started thinking, well, I know there are satellites out there taking photos of the Earth. Maybe I could somehow find that data to see if there's snow in these mountains. And that was when I discovered Copernicus, and I discovered those images, which are available. They're just difficult to get to in their current form. So that was the genesis of the idea, really. That planted the seed. I started thinking, wow, I would love to have an app where you could go and you could get actual satellite images of places. And from there, it just kind of snowballed into this huge project where then I discovered the other data that's available, like the snow cover and the sea ice and the land temperature and ocean temperature. And all the data was really cool. So I just started absorbing more and more of it. But it did start from that one little seed of an idea. Just started from, wanting to go on a camping trip and snowballed from there. So that was the origin of the app.
Thanks. Great story, by the way.
Thanks. Thanks.
Thank you. Mateusz, I think you're next.
Yeah. So, yeah, you've mentioned quite a bit about that. If we have the idea and probably some resources when it comes to, for example, abilities, just go for it. And yeah, like it's probably an amazing advice and like the way to go. But on the other hand, there is this thing that I'm sometimes wondering whether, should make the best possible application when it comes to, let's say, using the functionalities and stuff like that, versus be more engaging with like audience, with people around. And of course, like it's probably something in the middle, but for me personally, it's hard to navigate between like how I would like to develop it to be, for example, if we are speaking about the app, to be as helpful as possible versus like to be engaging with people.
Yeah, and that is finding the right balance there is really important, because I think you can sort of oversimplify things to the point where you do make them less useful. And yeah, it's sort of a lot of it, I think, has to be done based on feel and intuition, and finding that right balance between throwing in every single feature that you think of, as opposed to just having it be the simplest, most stripped down, cleanest app you can. There's always a balance there, and it can be difficult to find it. You can never please every single stakeholder in any project. There's always compromise that comes into the equation at some point. I just always try to think of, if I were coming at this app with no experience with it at all, no experience with the entire industry, if I were just coming in totally cold, would this scare me off? Would this interface be too daunting? Would it be too complex? I try to look at it that way. Is it inviting enough where it has enough power to kind of suck you into it to make you want to explore it more and get deeper into it. But yeah, I think a lot of it can come from, looking at apps, looking at software and technologies that you think are really well done, trying to sort of pick them apart in your head and think of what were the thought processes that went into this and that, and try to mimic those sort of that design methodology on your own. But yeah, it is, communication always helps a lot, just talking to various stakeholders and getting feedback. Sometimes, you might get feedback from somebody that you didn't think of at the time, but as soon as you hear it, it becomes so clear and you think, yeah, why didn't I think about that? But that's the sort of thing that can come when you do beta testing and you put things out there and you solicit feedback from people. So yeah, it's a process, but I think it's, you just have to be aware of, is it going in that direction where the engineers are taking total control and trying to put every single feature and every little checkbox into the app. If it goes in that direction, you're going to really end up compromising kind of the usability and the appeal of the project.
Thank you.
Mm-hmm.
Yeah, Sasha, go on.
Yeah, since our teams here are working with projects that will supposedly help in education, to help educate or in the process of education, I was wondering if you have any insight on how to process and work with the scientific data in a way that makes it more understandable and intuitive for regular people, you could say.
Yeah, that was a big part of Orbiter, was taking data, numeric data from a lot of these sensors and making it visual, because you will not connect with people through tables and numeric data in its direct form. So a big part of Orbiter involved taking that data, things I'll use as an example, I'll use ocean temperature. That's data that's available from the Sentinel satellites, but it's in numeric form. So Orbiter, on the back end, it goes and it takes all that data and it renders it out into color maps. And so, you see the colors overlaid on the ocean. That's the sort of thing where without that visual representation, you're really not going to be able to communicate data like that. So in developing Orbiter, I built a backend, which is called OPIE, which stands for the Orbiter Planetary Intelligence Engine. And what that is essentially is it's a server API for making that data available. So that's something that you can all check out as well. It's op.earth, opie.earth is the URL for that. And that data is available through there. It's still in development, but it is accessible if people want to try that out. You can do things like put a region in, if you want a rectangular region of coordinates, and you can say, give me an overlay of the vegetation within this rectangle, and it'll come back not with numeric data, it'll come back with an actual image, a color-coded image that you can then overlay on whatever you're building. So that's a Google Earth Engine has similar things as well, but I prefer OPI because I think it's really more direct and easier to use and more geared towards app builders rather than scientists. So have a look at that. I think there's some potential in there.
Would you please repeat the website again?
Yeah, it's opie.earth. I'll put it in chat. I don't know if we can all see it or not, but opie.earth. Yeah.
Yes, thank you.
Mm-hmm.
Thank you. Veronica?
Yes, so thank you very much for your inspiring talk.
Thank you.
I have the impression that technology users prefer to look into space, universe, rather than at the Earth from the space. how to do opposite. How can one person feel part of the Earth observation data, empathize with those data? Do you have any tips on how to enhance this involvement of individual?
Well, to me, the Earth observation data is really some of the most exciting stuff that's happening in terms of space. I mean, I've always been very into space and grew up watching Star Trek and all that, and I love, you know, thinking about what's out there in deep space, but there is the reality that it's all just so far away. We're never going to get to see any of it close up, and whereas the Earth is, you know, in some ways the most important single thing that we're all connected to. And so to me, the Earth observation stuff is the most interesting thing that's happening in space right now. And it has the most, and it has the most tangible kind of real world benefits, because you can do things like, you know, see where sea ice is and where it isn't. You can spot fires before people on the ground might spot them. You can see, you know, what's working in terms of farming and what's not. You can get a sense of where these algae blooms are likely to happen before they happen, things like that. It's all really tangible stuff that's easy to communicate, whereas some of the other things, you know, landing on the moon, I love this stuff. I love the moon landing and I love exploring Mars and all that, but you know, a lot of people, they come up with the question, well, why? What's the point? And it can be pretty hard to really come up with a legitimate answer to that question, aside from, well, because it's cool to do. But that's where Earth observation is different, because it is connected to so many important, tangible things that relate to our day-to-day life. And when I was building Orbiter, just being exposed day to day to all that satellite imagery and all the satellite data, I learned a lot of things that I wasn't expecting to learn. One thing that I touched on earlier is just the extent of deforestation and the scale of slash and burn agriculture that happens in the rainforests is so much bigger than I would have comprehended just by hearing all the stuff that you hear about it day to day. Seeing it there, seeing it visually, really opens your eyes and says, well, we've got to do something about this. This is a serious problem. So I think that's really, to me, that's the power of Earth data, is communicating those kind of messages. And you know, you can communicate one message at a time through some simple application or something, but using that real data to tell people about their own planet, I think is so powerful, and there's a lot of potential that's still untapped in that area. So I don't know what the next really great and powerful app will look like, but I think that there are opportunities, and I hope that some people really start thinking about it and trying to build those solutions.
Thanks.
Thank you. Any more questions from participants here?
It's going to be the last one, unfortunately, because we have to wrap it up. So last chance.
There is one comment on YouTube. It's not really a question. Someone wrote that what was said here, that collaboration with like-minded people can really fire things up. That was the best thing they heard today. So I just wanted to pass that here.
Oh, nice. I'm happy to hear it.
All right, if there are no more questions, I think we will wrap up. So thank you very much.
Thank you.
It was great to hear you. I hope it was very insightful and inspirational for the participants. Well, yeah, so that's
all right.
sort of...
Well, yeah, thank you everyone for coming. It was really a pleasure being able to talk to you all today, and I'm excited to see what else comes out of this week.
Thank you.
Thanks a lot.
Thanks.
Great.
Bye.
Bye-bye.
Yeah, I also
Thank
like
you.
to thank you.